This lesson is for FST. We're going to combine lessons 8.1 on arithmetic sequences with lesson 8.2 on geometric sequences. Students will need a graphing calculator to do this lesson. First, let's talk about what a sequence is in general. A sequence is a function whose domain is a set of consecutive integers. Hopefully students know what consecutive means. It's numbers that are right in a row or right next to each other. And if we're talking about the domain, hopefully students know that that means the x values. So if you look at the given sequence here, these numbers are not consecutive. These three are, but the whole sequence itself is not considered consecutive. So that means these must not be a list of the domain. So that must mean that these are the y values. So keep in mind that when you're working with a sequence, the sequence itself is the y values, and the x values, or the domain, those are where the consecutive integers are going to be. And so those consecutive integers represent what term number you're on. So if you're looking for term number 1, you know that's going to be the number 1. Term number 2 is the number 1 in this case. Term number 3 is the number 2, and so on. So the domain is the x values, and it represents consecutive integers because the sequence goes in order. And the domain represents the term numbers. There are two types of sequences that students need to know for this chapter. And there will be a lot of equations in this chapter, so students need to begin to memorize them. I'd recommend that you start making some flashcards for these. Let's start by looking at the arithmetic sequence. Arithmetic sequences are the focus in lesson 8.1, and they have a constant difference between the terms, meaning you're adding to get from one term to the next. So if you subtract the terms from each other, there's going to be a constant difference between them. Geometric sequences have a constant ratio between them, which means you're multiplying to get from one term to the next. In both sequence types, there are two types of equations that you can write to illustrate them. Both have an explicit formula and a recursive formula. The explicit formula has the advantage of being in algebraic form, and so if you're looking for solving a situation to try to find a missing term, the explicit formula is the one to choose. Also, if you're trying to find a term that's large, for example, trying to find term number 100, the explicit formula is a good one to use. You can simply plug in 100 for the n value and it'll generate the term that you're looking for. The recursive formula's advantage is that it's very easy to use in order to generate the sequence itself. So if you're given information and asked to generate, for example, the first 5 terms of a sequence, the recursive formula is a good way to go. So let's look at all the different parts of all 4 of these equations. The explicit formula for the arithmetic sequence has the first term given as a sub 1, so that'll be represented by some number, plus n minus 1, where n represents the term number, times the d value, which represents the constant difference between the terms. Keep in mind that if that number for d is negative, you want to make sure to put it in parentheses. Otherwise, it could look like you're subtracting the d. When you're working with the recursive formula in the arithmetic sequence, the first term is given as a separate line, and so it's linked with line 2 by the bracket. When you have a sub n minus 1, that means the previous term. Think about it. If you have a sub 5 minus 1 is going to be a sub 4. So to find term number 5, you would need term number 4 to do it. And all you're going to do there is take the previous term and either add or subtract the d to it. Know that these two could be interchanged, so you could have your equation listed as d plus a sub n minus 1. So know that it doesn't have to be in the order that's given here. Similarly, for the geometric, has an explicit and a recursive formula as well. So the explicit formula is, again, the first term given, but this time instead of multiplying by d, we're multiplying by r, and the r is being raised to the power of n minus 1, where n represents the term number. R is still the constant ratio between the terms, and g sub 1 is still the first term. In the recursive formula, again, indicated real clearly with the bracket, the first term is given as a separate line, and then the previous term is being multiplied by the r. Again, keep in mind that these terms could be flip-flopped, so you could have g sub n minus 1 times r, and that would be the same thing. So let's put these formulas into action with a bunch of examples. First example gives you a sequence, and you're asked to determine what type it is. Keep in mind that arithmetic and geometric are not the only types of sequences that are available, but they're the only two types that we will be studying. So if it doesn't qualify as either one, then you're simply going to say neither. This question does also ask us to give an explicit formula, so once we've decided, we're going to go ahead and write that. So you'll want to determine if there's a constant difference to get you from one term to the next. So in this case, 16 minus 12 is going to be 4. 12 minus 9 is 3. That's not constant, so I know it's not arithmetic. So now I'm going to try to divide to see if, or multiply to see if I'm getting from one term to the next. So if I do 16 times what is 12, the way that I would figure that out is I would divide to get the what alone. So I'd have to figure out whatever 12 divided by 16 is. And I know that that's going to be 3/4 if I reduce that. So I'm just going to reduce that to 0.75. Now I'm going to see if that's the same thing when I go from the second to the third. So 12 times what is 9. I could also take that same r value that I've already determined and do 12 times that and see if it generates the 9. But I'm going to divide by 12 on both sides, so I know I'm going to get 9/12 there. That's also going to be 3/4. So I was able to find my answer, that the r value is 0.75. Since an r value exists, that means there's a number that's getting me from one term to the next through multiplication. So I know that that's going to be a geometric sequence. So I'm going to go ahead now and write my equation. The explicit formula for geometric sequences is the first term times the r value, which you could give in decimal or fraction form, raised to the n minus 1 power. That answer would probably be sufficient, but since it says formula, make sure you get it equal to something. Now let's look at our other example here. It's pretty clear and easy to see here that as I'm going from one term to the next, it increases by 6 each time. So clearly that is arithmetic. So when I write my equation for that, it's going to be different from the one I just wrote. The first term plus n minus 1 times the d, which in this case I clearly found to be a 6. If I didn't have that answer real clear in my mind that I could just figure out myself, I would have done some subtracting there to find the difference between the terms. Again, make sure you set it equal to something so that it is indeed a formula. And I think I forgot to label back here that this was indeed geometric. Another type of problem that students are going to encounter is one like the next one, a theater problem. Always read a word problem thoroughly before you begin. A theater has 20 seats in the first row and 5 more in each subsequent row, or each following row. In the last row, if the last row has 125 seats, how many rows of seats are in the theater? So you can tell by the way that it's worded here, if there's 5 more in each row, that that's going to be an arithmetic situation because you keep adding 5 to each row. So I know that my D is going to be a 5 there. I know that the first row has 20 seats, so that's going to be my A sub 1. So I'm going to go ahead and write my equation for that. So I know I've got 20. I don't know what row I'm in, but I do know that I'm multiplying by 5 each time, or excuse me, adding 5 each time. And I know that I want to get to the number 125. So now if I solve that for n, I'll have my row number that I'm looking for. So I'm going to do the distributive property there. And then I'm going to add like terms. And then I'm going to subtract from both sides. And then I'm going to divide by 5. So the row then is row 22. Or excuse me, 22 rows altogether. Before I forget, I want to go back to this question back here. When students have this answer, that's perfectly fine, but I want to point out that the book may not have that as their final answer. The book doesn't like it when your final answer has parentheses in it, so know that if you try to check this type of an answer in the back of the book, it might not match. So keep in mind that I'm okay with you leaving it like that because that follows the formula that I've taught you. However, you might want to go ahead and get rid of the parentheses here. So you'd end up with 18 plus 6n minus 6, and the 6 and the 18 there can reduce to a 12. So know that that could be an alternate answer that you could give. Either the green or the blue here is perfectly fine, but know that the book will probably give the blue one as their final answer. So the theater question, we finished that one up. That one had 22 rows altogether, and that's where the 125 came from in the last row. And next one says find the next term in the sequence, and the sequence is 96, 48, 24, and so on. Keep in mind that there's no formula mentioned here. All you have to do is figure out if it's arithmetic or geometric, and then just find the next term. If you want to use a formula to do that, you may, but it is not required. So as I look at these, I can tell that it's dividing by 2 each time. Keep in mind that you want to think about it in terms of multiplication, however. So if you know that you're dividing by 2 each time, that's the same as multiplying by a half. So the R value here is a half. So half of 24 then is going to have to be a 12. If I want to find the 100th term in the same sequence, I definitely want to use the explicit formula there. First term is 96. I just found that the R value was a half. I'm raising it to the 100 minus 1 power. And when you do that, you're going to get a very small number. Your calculator is going to say about 1.5 times 10 to the negative 28th power. And the way that it's written on your calculator is probably going to be 1.5 and then an E and then a negative 28. So when you see that type of an answer, don't run away from it. It doesn't mean your calculator is wrong. It just means that number is super small. So we're getting a number that's got 28 decimal places to the left, or 28 zeros to the left of the decimal place. Another type of situation you're going to run into is like the next one where they give you 2 terms of the sequence, but they ask you to find the equation. The equation is going to require you to have the first term and the R value. So if we're not given terms that are right next to each other, we're going to have to use algebra to solve. So since it's geometric that we're doing here, I'm going to just review the formula. G sub 1 times R to the n minus 1 power equals G sub n. I'm going to write 2 equations using the information that I've been given, starting with the piece of information that's biggest or further away from 0. So I'm going to start with 375, and I'm going to start over here actually. And I know that that's equal to G sub 1, which I don't know, times R to the 4 minus 1 power, because the 4 is the x, the 375, the sequence, is the y. I'm going to do the same thing with the other piece of information I've been given. The 15 is the answer. G sub 1 and R I don't know, but I'm raising to the 2 minus 1. Let's simplify those a bit, because we've got some subtracting to do there. So I end up with 375 G sub 1 times R again, but this time I'm raising to the 3. Then I've got my 15, G sub 1 and R, raising to just the 1 there, because 2 minus 1 is 1. Now what we're going to do, since we have a system of equations, is we're going to divide those. The reason for that is G sub 1 divided by itself is going to cancel out. We need one of the variables to cancel, because right now we have 2. You can't solve for 2 variables in an equation, so one of those variables has to go away. So the way that we can do that is by dividing the 2 equations into each other. 375 divided by 15, we can figure that out. That's 25. The G sub 1's have canceled. And for the R values here, if you have R times R times R on the top, R cubed, divided by just R to the 1 on the bottom, we've got R and R there that are going to cancel, leaving us R squared on the top. The property of exponents that's happening there is you could also think about the exponents subtract. Now in this case, I know a lot of students can look here and say, oh, the R value is going to be 5, which is great that you know that. But I want to talk generally about what to do if the numbers didn't work out so nicely as they do here. If you're being raised to a power here and you're trying to find what the base is, you're going to raise to the reciprocal power to solve. So I know that 25 raised to the 1/2 power is the same as taking the square root of it. So I know that I'm going to get a 5 there, and I know that raising to the reciprocal is going to work no matter what. So that's my r value. I still need to find g sub 1. So if I plug r back into one of my equations, doesn't matter which one you use, but I would pick the bottom one here because it's going to have smaller numbers to work with. So I've got the 15 there, g sub 1 I don't know, and I just filled in the r of 5. It's 5 to the 1, which is still 5. And what times 5 is 15? Well, I know that by heart. That's got to be a 3. So g sub 1 has to be 3. And now I have my formula. Make sure you set it equal to something in order for it to technically still be a formula. Now when you're working with the next one, now it's arithmetic, so we're going to use the arithmetic formula. We're going to do a similar process here in that we're going to create two equations or a system of equations. So I'm going to say 4 equals a sub 1 I don't know. I'm doing the 6th term first, so the 6 goes in for n, and I don't know the d value. I do it again with the other piece of information I've been given. 14 is the answer. I don't know a sub 1, but I know that I'm working with term number 2 this time. I'm not going to divide these equations into each other, I'm simply going to subtract them. And what you're going to find there is, before we do that, we need to simplify. Resist the urge to do the distributive property here, because you don't need to. 6 minus 1 is simply 5. So we're going to get 4 equals a sub 1 plus 5d. Similarly, on the bottom equation here, 2 minus 1 is simply a 1, so we just get d there. Now let's subtract the two equations from each other vertically. 4 minus 14 is going to be negative 10. The a1's are going to cancel. That's the whole reason that we subtracted there. Division would still have the same effect on the a sub 1. A sub 1 divided by itself would cancel, but it's better for us to kind of stay consistent. Arithmetic sequences add and subtract to get from one term to the next, so we want to subtract the equations to find what we're looking for. And then 5d minus 1d is going to be 4d. If you divide both sides by 4 there, you get negative 2.5 for d. So again, I plug that back in to one of the two equations. Usually I plug it into the bottom one because that's got smaller numbers. And when I do that, I get 16.5 for a sub 1. So then you just need to assemble the pieces. So 16.5 for a, n minus 1 goes back to being letters. Make sure you put your d in parentheses, otherwise it looks like you're subtracting a 2.5 and we want it to be multiplied. And then just set it equal to something. Final question that we're going to do here is a word problem. Word problem has percents in it, so even if it didn't say that it was geometric, the fact that there is a percentage there indicates that it is indeed a geometric situation. Be careful here because the investment of $500 is not the first term. This is actually going to represent year 0 because it's the initial investment, but it's not the first term. The first term is how much you have in the account after the first year. If you plug in $500 into your account after a year, it will have gained interest. So the first term of the sequence is not 500. So be careful here, you're not going to write 500 times r to the n minus 1 power. That first term is 500 with interest. So we have to figure out that first term. So when we do that, there's two ways to do it. You can take the percentage and multiply by whatever you're investing. Just make sure you do that as a decimal. When you do that, you're going to get the amount of the increase, so you'll still have to add to that the original investment. Another way to do that more quickly is to simply say 500 times 1.045. That'll get you your answer much faster. The benefit there is now you can see what the r value is. There's your r value right there. So let's go ahead and calculate what that is because we need that to be our first term. So if you type that in on a graphing calculator, you get 522.5. So there's our first term. And then our R value, if it's an investment, you just take your percentage rate, change it to a decimal, and add a 1 in front. Don't forget to raise it to the n-1 power and set it equal to something. And so there's your explicit formula. And finally, just want to mention that you've been exposed to arithmetic versus geometric before. When you've done a mean in the past, or an average, you're used to doing the sum of the numbers divided by n being the number of terms it has. That type of mean is referred to as an arithmetic mean. There's another type of mean called a geometric mean. That's when you take the numbers and multiply them together and take the nth root. That's not a main focus of the lesson, but I wanted to just bring that back related to the fact that we did arithmetic versus geometric sequences today.